Okay, hello everyone. Good morning, good afternoon, good evening, because there may be people from different continents. So my name is Sergey Akavenko, for those who uh, have not met me. And today I would like to share some new things that probably are familiar partially to the audience because I looked at the list of people who signed up, and there are a lot of old friends. But still, there is new stuff that I wanted to share. First, I want to tell you a little bit about what this design for patentability is, from where it came, and in what direction it is heading now, what is happening with this DFP in the world. Um, there are a number of innovation technologies of design, let us put it this way, of different caliber, different power, and probably one of the most known and spread was innovative technology of design that had been using TRIZ, theory for inventive problem solving. Many know about it. And TRIZ has many different applications. It can be used for improving product and processes, developing new ones, technology forecasting, strategic planning, and so on. So quite long ago, when I studied TRIZ from Henry Altshuler and different TRIZ tools, including function analysis and trimming, that basically is about of taking a product that you want to improve, dismantling it into components and describing functions that components perform. And then one of the possible tracks of improvement would be removing components that give you headaches. But because we have done function analysis prior to it, we know exactly what functions this problematic component performs. So when we throw it out of our system, we redistribute its useful functions among the remaining parts. That's a very powerful approach because, first of all, it is very counterintuitive to engineers who had been trained how to make things work. If things do not work, it's our task to make them work. And trimming suggests totally different things, kicking out a component and basically teaching other components to perform its functions. And at that time, basically, because I had uh, time in my life when I had to actually draft a lot of patents, a lot of patent applications because of using TRIZ. Among other things, I got my master degree in international patent law, though I never kind of practiced as a patent attorney. It was not my dream in life. But at that time, it caught my mind that this approach would be an interesting strategy for walking around competitive patents. For example, taking a claim of a competitive patent, um, uh, dismantling it, seeing what components are included there, just performing function analysis on the claim, because all the information, what functions every component performs, usually are provided in the description of the patent. And after that, using some criteria, try to trim one or two components mentioned in the claim. It would give me new problems to solve. I use problem-solving techniques to solve these problems, enabling remaining components to perform functions that had been delegated to them. And this way, I get a new architecture of my design, preserving the same set of functions that the competitive patent used to perform. So basically, I perform the same set of functions, and some components that are mentioned in the claim of the competitive patent are missing. And most likely than not, while we are doing that, we change the remaining components. And those changes quite often constitute some patentable features. So I tried it. It worked like a charm. And since then, I'll truly recommend it actually to do research on that, and that was my TRIZ master kind of topic of my dissertation. Since then, we considered that TRIZ, one of the applications of TRIZ would be um, different IP strategies. And for a number of years, there were workshops that I conducted and some other people conducted that were called TRIZ for IP strategies. The interest towards this topic was pretty high because companies that have intensive R&D are very interested in kind of protecting what they develop. They are interested in walking around competitive patents without buying a license, and of course without infringement. It saves time and money. Besides, they can use the same approach on their patent application that they're going to file that will strengthen those and basically allow them to fortify their patent applications for, against the infringement of other by, not infringement, circumvention by others. So everything looked fine. I used those things and they were working pretty efficient. But with time, I noticed that though people understood the approach, the results of, the outcome of these efforts was not that great. Some people could use it, some people could not. And that's, when that brought things to my mind that probably something is missing. Probably this has not been developed granular enough, like with the early TRIZ methodology, that it was exciting, it sounded very reasonable, but not many people could use it. So that's when I started kind of looking into that, in developing those smaller granular details that could be pretty practical. And that's it was like an eye-opener because the diversity of patents, the way they drafted, the way they are, is very different. And one approach like that, though theoretically, conceptually, it is the same, it works very, very different depending on how the claim of the competitive patent is drafted. And there are different approaches how to use those tools to walk around it, or to strengthen it, or to identify white spots for patenting, or developing firewalls, or how to perform innovative hybridization, because actually this patent circumvention all of a sudden, revealed quite demand in companies with developing economies. In China, probably, not that many people get appreciative of TRIZ and different innovation technologies in general. But walking around competitive patent turned out to be extremely popular and in need in China, especially now, when the quality of Chinese products became pretty good. They are not expensive. And what they did prior to now, they just took inventions patented by European countries, US and other countries, and those that had not been patented in China, and they used them successfully in China, manufactured and consumed in China. But when the quality it was not violated, no violation, because those engineering solutions had never been patented in China by European, US, and other companies. But when the quality of Chinese products became pretty good and competitive at other markets, they would be happy to bring those products to those markets, but they cannot because those patents are still valid on those markets. That's why many Chinese companies are ready to pay any money for a successful circumvention those competitive patents that they had been using in their technologies, because it opens mm, new markets for them. Um, but also in countries with developing economy, there is a different situation because markets require products there, and there are products. But the products are usually brought by multinationals from outside, and they are patented in those countries. So the country has resources. The country has labor, cheap labor, but they cannot really copy and reproduce the needed products because they had been patented in their countries by multinationals. That's why the ability to walk around those patents would be a golden key for the national companies, small, medium, these new enterprises. Entrepreneurship is very popular there now. So it will be a golden key to basically elegantly walk around the competitive patent of multinationals, get freedom to operate, and use their, not expensive labor and their capabilities just to fill their markets with, copies of those popular products without really violating anything, just getting freedom to operate. They do not think about patenting their own ideas, but at least getting freedom to operate. So the demand for this type of services, for this type of methodology has grown dramatically. I mean, and it grows. It's very different from what I felt 2 years ago. Right now, it's like an avalanche. So basically, this inspired me, to focus on this direction more attentively. In addition to this, friends of mine, because I have friends with whom I studied, with whom I, got my LLM, and they have become professionals. They're litigators. They go to patent courts and they, participate in patent lawsuits. That's their full-time job. And they gave me a couple recommendations that, for example, calling it for like TRIZ for IP strategies, that's very consuming because in IP domain, IP strategies, it is something different that is meant behind this term. It is like filing strategies, licensing strategies. But what this approach offers, it's rather the engineering side of it. It is not what patent agents and attorneys do. That's a little bit beyond their scope of interest. It's adjacent, but it is not exactly theirs. While this design for patentability, like technology that allows to do engineering design. We do engineering design anyways with that methodology or another methodology. But this one will inevitably lead to innovative, powerful solutions. But on top of that, like a cherry on the cake, they will almost automatically satisfy criteria of patentability. So if you choose to protect your innovative development, that would be, much easier to do than the other way around. When we design something, and after that we start checking, is it possible to protect it? And sometimes it has been designed already in such a way that IP protection is extremely difficult, if not impossible. So that's why I changed the name from, IP strategies using TRIZ. And there are, by the way, right now, there are a lot of other things that are not a part of TRIZ, but they contribute to achieving the same objective. So it's like I would rather position it as innovative technology of design, a pretty organized, pretty disciplined process. From that perspective, it is similar to modern TRIZ that is called whatever, TRIZ Plus, systematic innovation, pragmatic innovation. Right now, this modern TRIZ has a plethora of different names. So, but a major feature of that, it is a very disciplined and organized process. And design for patentability is kind of the same way. And it has kind of two branches. One branch, it is when we are designing new things and there are recommendations and rules, what tools are better to use to have an outcome that is an innovative solution that achieves projects of the goal, but at the same time, it automatically satisfies criteria of patentability. And the second branch, basically IP-based projects, that's about walking around competitive patents. That's about strengthening your own IP, and as I told you, identifying white spots, developing firewalls, and projects of that specifics. Innovative hybridization. Innovative hybridization, that's another gold mine, because it's good direction for entrepreneurship. I have been involved in different entrepreneurship programs, and that's what 60% of entrepreneurs do. But hybridizing, bringing several systems together in one hybrid, yeah, from engineering perspective, it makes perfect sense and it can be successful. From IP perspective, it is not that straightforward. It can constitute quite an issue, when it comes to protecting a hybrid. Those who attended my classes, at some point, I usually give an example that when you combine things, and the example I usually used, it is a laptop that is usually typically heavy, the ones I have. I suggested to equip that my laptop be equipped with wings. So when I walk, the laptop is following me using its own wings. I don't need to carry anything. Supposedly, this hybrid, this solution deems to be very successful, and they want to protect it. Unfortunately, it is not that easy, because one of the criteria of patentability, novelty, not novelty, the inventive step, or non-obviousness, that one. Novelty, it is probably relatively easy, because maybe you have never seen or heard about laptops with wings, though, actually there are in animated cartoons and different pictures, you can find laptops with wings, so that would probably compromise the novelty. But supposedly no one had thought about this. But as for inventive step, it is not that obvious, it is not that clear how to protect it, because the patent examiner will definitely dismantle your laptop with wings into wings and laptop, and each of them is performing functions known functions for which they were designed. So no functions, known methods. That is why, where is the inventive step? The hybrid cannot be protected, or pencil equipped with the eraser. How to protect that? Exactly, known things performing known functions for which they were designed. With innovation hybridization, there are their own rules how to make those things patentable. Again, using some techniques from TRIZ and other methods, building function models of both hybrids, and then using functions of one parent to improve something in the second parent, and vice versa, to perform so-called cross-linking, right? This way, we will get some synergetic effect, like with the computer with wings. I will reply to the patent examiner that, he missed one thing in my application. I attached the wings in such a way that they automatically cool the chip while the wings are moving my laptop. And because of that, the laptop is working better. So I get that synergetic effect. I get this linking that cannot be seen in either of these parents. I get this synergetic effect only when I put the parts of the hybrid together. And that thing, makes it possible to patent the hybrid. And there are, now, within this design for patentability, so it's not really a part of TRIZ, it is new. There are guidelines, rules how to perform this cross-linking so that the hybrid, potentially can be patented, more or less easily, or the pencil with the eraser, right? So I would basically analyze the functions the eraser can perform through properties, and there is a special kind of part how to convert properties into functions and so on. Eraser may be soft, it convenient to hold, it is congruent with the shape of the fingers. So basically, what if the eraser is capable of sliding along the pencil, and when I just use the pencil, that's where my fingers are holding the eraser. But when I need to erase something, I actually move it to the end and use it for, using its main function, right? So my point is that all these different rules and new things within design for patentability, it is not really, a direct part of TRIZ or any other method. And this part of design for patentability has been growing. In the beginning, it was just a little bit of new things, but 90% it was TRIZ. Now, it is expanding. So now it's expanding. So this methodology, I think deserved like a separate name, because right now about 40% of it is not what we have in TRIZ, and on the contrary, the rules of using those tools are not really the rules that are recommended within TRIZ. They are different. Yeah. In the past, we usually, had something like when we build function analysis using the rules of function analysis, components must be substances and fields. And we made a point that holes, openings, orifices, these things, passages, they cannot be components because it's a hole. Hole cannot be a component. But when it comes to walking around competitive patent, if the claim of the competitive patent, the independent claim of the competitive patent happens to have hole mentioned there, hole should be a component there, because trimming or getting rid of the hole will give me an opportunity for freedom to operate. Now, the number of recommendations of that type, it is, I don't know, dozens of times more. That is why, I would rather say that the method uses TRIZ tools, but not exclusively. There are other things. Within TRIZ, there are ways, there are methods how to identify white spots, where there is a high probability of patenting still exists, so to get away of very busy areas where every hair has been patented. But there are other tools for that, that are beyond TRIZ. So to make a long story short, that's how this design for patentability emerged. And another thing that pushed me, it is the fact that miraculously, it attracted attention of a lot of IP professionals. Though, as I told you, that is probably belong more to R&D engineers, for patent engineers, that work within companies. Of course, there is a certain part of IP professionals, that are more involved in engineering aspect of IP. But still, first of all, number of patent offices showed interest, and actually there were training workshops in those, a number of those in China, in South Korea. In South Korea, that happened because of deployment of TRIZ and innovation methods at major South Korean companies, Samsung, POSCO, LG, Hyundai Motors, and so on. In Poland, in Poland, it was also kind of interesting. Polish patent office was really contributing to deploying TRIZ in Poland. Ex-president of Polish Patent Office, Pani Dr. Alicja Adamczak. She was really a very strong promoter. She retired, but she is a very innovative person herself. And because of her efforts, basically this direction is propagating in Poland. They were training workshops, several of them, in Swiss Patent Office. I was very proud of that because that's where Einstein worked, and this Swiss Patent Office, well, it's called Federal Institute of Intellectual Property. It has quite aggressive, quite extensive different training programs there, and they brought this design for patentability there several times. There was another confirmation that we are on the right track. There is also a very prestigious organization. Many of you probably have heard about it. It's WIPO, World Intellectual Property Organization, a specialized agency of the United Nations. And they run very, very, very diverse activities in IP area. And one of those is promoting IP knowledge and educating IP professionals. Because WIPO is an agency, but they cannot grant any scientific degrees in any area. That is why they launched a number of programs where they fund an educational institution, and there are about 15, I think, of those in the world in different countries. And those institutions, they open schools, departments, colleges, centers, different names of intellectual property where they grant master degrees, LLM, and WIPO is funding those. One of the most prominent universities that started it quite long ago, by the way, in Poland, it is Jagiellonian University. They started such a program a couple of years ago. But one university that was a pioneer, or one of the pioneers who had been doing this type of program for a long time, is Tongji University in Shanghai, China, a pretty prestigious school, pretty high ranking. And they opened this Shanghai College of Intellectual Property that is a part of Tongji University. And WIPO has a pretty extensive program there that is called IP for Design, training not lawyers, but kind of patent engineers or, well, IP professionals, let us put it this way. There is some parts on patent laws, and the degree is called IP in patent, international patent law. But in Tongji, the program is called IP for Design. Basically, how to protect a developed innovative solution to the best of the abilities of the expert, of the specialist. And when this design for patentability kind of, got into their radar, they immediately grabbed it because they say, well, that is the same bridge, just two different sides. We are training how to protect an innovative solution the best way. And design for patentability basically instructs how to design things that when they come to the finish, to the final point, they would automatically satisfy all the criteria for patentability. Because it's like two sides of the same bridge, we must bring this methodology into a WIPO program. And we started it 2 years ago, and it was a blast because, people who study there, first of all, they are IP professionals from all over the world and pretty kind of high-ranked professionals. We have, heads of IP, services, governmental services from different countries, or basically high position people there. And also a lot of the engineers that really do practical work. Many of them actually started their kind of IP consultancies that provide not only legal services like usually a patent firm provides, but also they opened actually consulting for their customers to instruct them on engineering side, how to actually what changes should be done in their design from engineering perspective to strengthen their IP, to protect better, developing dependent claims, that's also there are tools for that, how to develop valid, strong, dependent claims, and so on. So all these things basically keep on strengthening my mood, the fact that we are moving in the right direction. And I would like to just have not only just promotional things and tell you wonderful things that have been happening with this methodology, but also I want to dedicate some part here about the engineering side, because some people, I saw the list of people who subscribed for the webinar, some of them are practicing the kind of engineering side of this innovative technology of design. Some of them already heard about, for example, using trimming for walking around competitive patents or substitution, because those directions have been known. And as I told you, I had conducted a number of those workshops. But I wanted to show a little bit of details, especially kind of new things. And in addition to those, there are many more similar ones. What changed and what new is there in the kind of methodological approaches. So that is why we have these several webinars. We have 3 dedicated to different aspects, to strengthening your own IP, to innovation hybridization, that is how to create hybrid resulting with a patentable solution. But this first webinar is about competitive patent circumvention, because I told you it's probably 50% of those IP-centered projects. I told you about 2 branches. One branch, it says designing things or improving things and using tools, recommended in a specific way, so you get patentable solution in the end. And IP-centered. So this is kind of IP-centered. Probably 50% or more of projects of that type are about circumventing competitive patents. So I wanted to share what is new there. So to walk around competitive patent, as I told you, there are kind of 2 big directions. It is trimming, basically taking the independent claim of the competitive patent, decomposing it, similar to performing function analysis, but there are different rules, of basically building function model of the claim, not like in a usual function model. And then trimming a component or 2, and because we know the functions, every component performs, we redistribute them among remaining components. That's it. That's what we knew. You know what? It is not that straightforward, because when it comes to trimming, it really depends a lot on how the claim of the competitive patent was drafted. Sometimes the claims of the competitive patent, they are, I call them component-based. So basically, it's a list of components and their hierarchical structure, what includes what, and that's it. When the claim is component-based, then this approach, just using trimming, throwing out components and redistributing their function, it works well. In that case, probably you will be successful. But there are different ways that you can come across how people draft their claims. Sometimes there are claims that include some very basic components that are mandatory, for operating of this device. That goes without saying. And all the novelty, all these patentable things, the competitor got by describing, what these basic components, what functions they perform. So they perform somehow sets of functions that are not usual for them. In that case, we build function model of that claim. There are very few components, and all of them are basic. I cannot trim anything. I cannot substitute anything. That is why usual trimming approach does not work. So if claims are drafted this way, in that case, we just need to deal with shuffling those functions. So we need to redistribute those functions in a different way, of course, with getting some beneficial result. But trimming will not work there. And also it is not the substitution. We cannot substitute anything. So it's basically reshuffling the functions among the components that are there. This track probably is the most practical for this type of the claim. Sometimes there are claims that are drafted differently, so there's component based, right? There are function based when we describe these basic components, but the trick is what functions they perform. And there are also claims with so-called, I gave them a name, dragon patterns. I will talk about that. For those things, trimming usually doesn't work. This is kind of what I already developed more granular. That's why I wanted to show you about that. Then, in addition to components, there are attributes there in the claim. There are a lot of things, or there are maybe basic components, but the whole trick is where they are located, in what direction they're moving. When they start working, these details also can be included into the claim. Based on that, actually, there's a new thing that trees or other methods don't have: attribute analysis. We can analyze those attributes, where and what direction and when. And if we change these attributes to different ones with some beneficial result, we can come across a contradiction, because this component should be positioned in this place, to get one set of benefits. But I want to walk around this pattern, so I move it to another place and get another set of benefits, but I lose the first combination of good things. So this attribute analysis performed rightly can lead us to attribute contradictions. And then, of course, we need problem-solving tools from TRIZ. And the outcome, we will, without any trimming, just changing the attribute, and changing the components that the claim includes, can give me a circumventing solution. So basically, just direct rough trimming, it does not work every time. That is why those multiple attempts, when people got excited when they heard about trimming for walking around competitive patterns, it did not work, because depending on how the claim is drafted, you have different approaches. Right? When it comes to substitution, there are its own things. The prosecution history, estoppel, and doctrine of equivalence should be taken into consideration, and those have a plethora of their own recommendations how to deal with this, using the tools again from TRIZ and from other methodologies. So I'll just give you 3 case studies about patent circumvention. The first one just uses trimming, taking a patent, dismantling the claim, describing functions every component of the claim performs, and then trimming something and delegating its functions to remaining components. After that, we solve this problem. We need TRIZ problem-solving tools. By the way, the part when it comes to solving the patent circumvention problem that arose from our analytical activities, for problem solving, there is nothing better than TRIZ. We have to use TRIZ problem solving tools. You know, it goes for granted. But DFP, where it is different with the analytics, you know, how to formulate that pattern circumventing problem. That might be very different from traditional TRIZ tools. So very quickly, you know, this is metallurgy, one of the largest steel companies. I would not say the largest, but they're pretty big. You know, they are one of the largest in Russia. Right now, they are in other countries, in India, in the United States. It is Novolipetsk Steel, or, you know, steel company, NLMK. And that's where this project was. It is not very new, but at that time, you know, trimming, I used trimming just in its simplest form. So that is making steel in the converter. So pig iron from the blast furnace goes to this converter. It contains a lot of carbon, and the carbon needs to be burned out. So they blow liquid metal with oxygen, well, high pressure, 11 atmospheres. So the oxygen goes into the bath, gets connected with the carbon of the pig iron, you know, generating CO and CO2. And basically, in the converter, we manufacture just clean steel with very low % of carbon. So as I told you, 10 atmosphere oxygen is going through the lens into the bath. And CO and CO2, of course, CO, it is poisonous gas, and also it generates a lot of dust. So everything is come out of the converter, and there are a number of patents about these, you know, how to catch these gases, poisonous and polluted with dust, how to clean them. CO is flammable. It can be used as a fuel. We can burn it to generate steam and other forms of energy. So the company for which I work, they developed some interesting technology for this converter, for basic oxygen process, another name for it. But they wanted the license, they wanted to license the whole thing, not only the technology of making steel, but also the whole complex, you know, with the gas cleaning part and, you know, utilization part. And there was nothing new in that gas cleaning part and energy utilization part. That's why it was necessary to develop something or to make patentable whatever had been developed. So there's a number of patents. So there are different systems how to catch this. On the left, you see this container, that's the huge converter, and it goes through, you know, heat exchangers, through boilers, you know, to use the temperature of that gas. It's 1600 Celsius. It's very hot, right? How to catch dust, and then it goes to the Venturi tubes, you know, where scrubbers, where the dust is captured, and so on and so on. And then this water, you know, with captured dust needs to be treated, needs to be actually filtered. The dust needs to be briquetted because it is returned back into the converter because it's metal containing dust. You know, it is not that it's not rational just to throw it out. And there are a number of those different patents about gas cleaning approach and energy utilization approach for this converter gas. So build function model, you know, of a couple of patents, including all these things. And after that, we decided to do trimming, to trim not one, but many things that are included into this gas cleaning complex, you know, from this approach, and we delegated the function of basically treating the gas and returning the dust back to the metal bath. We wanted to delegate it to something that is a part of the converter. And again, to make a long story short, you know, the solution was the following. So we have 11 atmosphere oxygen that is blown into the metal. So the lens was changed. There is an injector, if you can see on the picture on the right, an injector through which the oxygen goes. An injector sucks in the converter gas with dust, CO, that is emitted from the surface of the bath, and it sucks those things into the converter, into the melted metal, with the same flow of oxygen. So the oxygen that is going into the converter with the level of atmospheric pressure through the injection system, it itself returns the converter gas and dust back to the converter. So the whole monstrous, multi-million-dollar gas cleaning systems basically could be thrown away, because all the gas and the dust that is generated is returned back to the melted metal by the oxygen, by the oxygen lens itself. And we got a number of patents on that, because there are several things to protect. Actually, because that's probably the only invention I had that generated enough money for me to buy a good car. Yeah. So, but that was pure trimming. There are, when we decomposing the claim, there may be so-called ghost components. Ghost components are components that are not explicitly mentioned in the claim. They can be considered attributes, or just we can figure out, there are rules how to do it, and extract those ghost components and put them into our function model of the claim. Again, I do not focus on those details of those rules, just an example. Another company, British American Tobacco, they are number 2 within the premium cigarette products. The first one is Philip Morris. And Philip Morris is a pioneer in electronic cigarettes. So the projects and training programs of British American Tobacco included a number of patent circumvention projects. And that was one of them, to walk around the patent of Philip Morris. If you read this claim, basically, there is not much here, very few components, that there are several heating regions that heat the tobacco, and they are turned on sequentially. And nicotine is evaporated, from one section, from another section, and so on. And that's it. So if we build function model, there are not many things there. So to circumvent this patent is not that easy. But on top of that, there are, why I mentioned this example, there are some ghost components that are not explicitly mentioned as a component. For example, it says that the heater, it consists of plurality independently controllable heating regions. So you see, they say that heating regions of the heater are independently controlled, but there is no explicit controller in this system. So just one example of that ghost component. So when we build function model, we need to put a component controller that is not explicitly in the claim, but it is there. And there are other types of ghosts that could be extracted, and there are rules how to find those ghost components. So what they did here, they actually trimmed many things, except all the heating regions and the controller. So basically their idea was to have one heating region, one thing, and through this heating region, the heat is going automatically by itself without any control from outside, something like through a candle. You start a candle, and after that, the candle controls itself. The heating region is moving along the length by itself without any interference from anything else. And using function-oriented search, again, TRIZ problem-solving technique, they found so-called electric candle technology developed long, long ago in Russia. So this electric candle, it is 2 electrodes with the plaster with the dielectric in between them. They apply voltage and it generates an arc there, ionizes air on top, generates an arc with high temperature. It was invented as a source of light. It was used for lighting the streets. The arc has high temperature, so it is burning. The electrodes are made of carbon, so the electrodes are burned, as well as insulation material between them is also burned. And this candle, basically, it works like a candle, though it is ignited with the voltage, because it ionizes air, at the edge of the candle. In the electronic cigarette, of course, we don't need to burn there's no flame. That is why these electrodes are made of metal. But there is something in between that actually, makes the circuit shorter. That's what we need, because when two halves are connected, that's where the hottest spots of the whole electrical circuit is. And as the result, together with the team, we developed a number of concepts. Paper between the electrodes, and the edge of this paper is carbonized 100. So the electrical current is going through this carbonated part, because carbonated paper is a conductor. So paper continues burning. So the length of the circuit is decreasing, and the hot spot where the paper is kind of burning, the hottest spot of the electrodes, is moving along the length of the electrode by itself. And there are a number of other solutions of shape memory metal. How can we live without shape memory? Two electrodes connected, and of course the connection point of two materials, it is the highest resistance. That's why it is the hottest spot. And because of the temperature, the electrode with shape memory, clings to the regular one. That is why the circuit becomes shorter. And that joint point keeps on traveling along the length of the electrode. So the heating region, the hot region, is moving along the length of the cigarette itself. The same thing with bimetals, a cheaper version, and using shrinkable film. You put these two electrodes in a shrinkable film. At the junction point, again, the temperature is the highest. The film shrinks, pushing those two electrodes together, and that would shorten the circuit. And again, the joint area, where the electrical current turns, keeps on traveling along the length, basically without any controlling device, without any controller, and everything is happening by itself. So here we had a ghost component. It helped a lot. And here, again, we used function-oriented search, for dealing with the problem solving. And the last example, the dragon patents. That's not a good term, I think. That's what they told me in Asia, in China. But I had my own considerations, and it's funny. I started using it jokingly, and now I look through publications of pretty big IP conferences, where patent attorneys were discussing some things, and I found that some people refer, to dragon patents using this term that I invented. Why did I call a dragon? There is a Russian story, pretty mundane, about a city that lived peacefully, and a nasty dragon settled nearby. In European and Russian culture, dragons are usually nasty. In China, dragons are good guys. They are wise and strong. That's why in China they told me, no, wrong name. But okay. So the dragon was terrorizing the city, asking, for food and other things. And they could not get rid of this dragon. So from time to time, heroes showed up trying to protect the people, to liberate them, but probably dragon ate them because they disappeared. So a new hero showed up, promised to kill the dragon, went to the place where the dragon lived, and killed him. It was very easy. But then he felt tired, and he decided to sleep for a little bit. He slept, woke up, and ran to the city to tell people that they had been liberated. They were free. But when he was running, he felt something was kind of different. He could not run as fast as he usually did. He turned around and he saw a long dragon tail behind him. It was not difficult to kill the dragon, but if you killed the dragon, you became a new dragon. That's why dragons lived forever. So there was a project that I came across at Hyundai Motors. At Hyundai Motors for 12 years, every year, there's a big TRIZ program from level 1 to level 3, and 50% or more there, it is patent circumvention projects. So that's one of the strategic kind of decision of Hyundai Motors. They have a special team that identifies patents of competitors that are strategic and very popular on the market, and you use DFP for walking around those patents. There are a number of articles actually that Hyundai engineers published, describing the cases where they use DFP. So that came from Hyundai Motors. So they pay a lot of attention to. I'm a little bit late. Attention to safety. So the most dangerous seat in the car right now, it is the back seat, because the front seats are protected with about 12 airbags. So they wanted to protect the backseat passengers, because in case of side crash, the left guy smashes into the right guy, and the right guy smashes into the wall. So, but they had an idea, to have a airbag, that deploys between the passengers. But unfortunately, they found a patent of Honda that already protected that. The airbag that got deployed between the passengers, and there was a supporting kind of wall, supporting element inside. So, okay. So they decided to circumvent it. So they decided to trim the supporting element. But the supporting element was not mentioned in the claim. In the claim, it was just means of support. And you see, if you trim means of support and delegate the function to support to something else becomes means of support. It's like that dragon. You killed one, delegated its function to another, and the other became the new dragon. Because means of support, means of heating, it covers everything. That is why when they decided to trim this supporting thing, and delegated the function to the roof, when the airbag deployed, it get hooked there to the lock in the roof. But the patent team of Hyundai said, no, that's that means of the means of support. It is infringement. So, and they blocked, that patent application. What to do? Well, when we have dragon patents, we need basically, we need to do trimming in such a way that, but we do not change anything when we delegate the function to support to a new component. Usually the component remains, but there is changes of shape, for example, and there are a number of other recommendations. So what they did, they developed the airbag that deploys, but the shape of the airbag is such that it touches the walls of the salon. So basically, the walls of the salon serve the function of support, but you see, they did not introduce anything else. So they were patenting the shape of the airbag that is deployed, that it exactly fits between the walls. This way they killed the supporting things, but at the same time, they did not bring a new dragon. Unfortunately, this solution did not pass verification because it is too big. That's why the time of deployment is too long, and also it occupies a lot of space for the in the car to keep because it's big. So they had to do something, but they're very persistent. They came up with another idea. They use the headrests, as a kind of supporting thing. So they patented the airbag that has such a shape that when it gets deployed, it fits between in this space between the headrests. So the headrests serve as supporting elements. So you see, when we start doing specific things about patent circumvention, it is not that primitive and it is not that easy. And the devil is in details. We need to know the specifics for different claims that are drafted very differently for different situations. So right now, this direction of patent circumvention within DFP, it is a set of rules that would address all these different nuances. So in South Korea now, it is at practically all big companies. There was a newspaper, there's a central newspaper, there is a section, Hello CO, about these DFP programs for Hyundai Motors and Samsung. It went to academia now. The number of universities in the States, Purdue University already has kind of this course, that is now stuffed with these new developments of DFP. Well, basically, that's what I wanted to share about patent circumvention part. But there are some other things. The next webinar will be about strengthening your own IP, and also there are different ways how to make your patent application stronger. And the third webinar is about this innovation entrepreneurship, if I'm not mistaken. All right, so that's it. That's what I wanted to share today.